In this video, we will talk about programming style rules for variables. We will start by listing some generic rules that apply for all types of variables, and then we will describe some specific variable rules. And finally, towards the end of the video, we will look at variable keywords such as constant, static, and volatile. Let's begin. We're going to begin with the three generic rules for variables. The first rule is you shall always follow the camel case convention when naming a variable. For example, if I have a variable that holds a count of my total apples, it will take the following form. It's an unsigned 16, and it will take this form, total apples, where the very first word of the variable name starts with a lowercase and then the second one starts with an uppercase. And let's say that I've got 15 apples. And similarly, if this variable had a third word, for example, total red or green apples, then the middle word is also going to have it's going to start with an uppercase letter. That's the camel case convention, and that marks rule 1. And the second rule that we need to follow for variables is that we shall always use clear and descriptive names. So, total green apples, this is a good example. A bad example for naming this variable would be something like this. Maybe TTLGN apples, assuming that the reader can understand that this means total green apples. This is a very bad name for this variable because it's not clear and nor descriptive. So you should always use very clear and descriptive names when it comes to variables. So total green apples is a perfect name for this variable. And now the third rule is when naming multiple variables, you shall always put them in a new line. You shouldn't define variables at the same line. So if I've got another variable that counts my total red apples this time, then if I define it at the same line, so total red apples, and let's say that those are equal to 17 apples, this is a bad way to write the variable. You should always define it as at a new line, and that's the third rule. So this variable shouldn't be at this line, it should rather be at its own new line. And there are some very good reasons for following this rule. Mainly, if you happen to modify a variable or perhaps comment it out, if it's at the same line as another variable, you might accidentally comment out or delete the entire variables at that particular line. So you shall always put them at a new line. And if you're working on safety critical applications, this rule is fully enforced because you don't want to get into troubles if your system is very high safety and critical system. So never underestimate such rules. Okay, now these are the three generic rules. Now let's take a bonus. If we have multiple variables defined at the same series of line, then it's a good practice to align their values and their names. So the names are already aligned on the left hand side, and if I add a third variable, let's say a floating point, and that's vertical speed, for instance, and that's equal to 12.50 f, for instance, then I should align the variable name as well. If I'm defining a series of variables and the following lines of each other, I should align the variable names and values, because this is going to make it extremely readable and very easy to look at your code. And it's beautiful as well. So this is a bonus on rule 3. Now, let's get into specific cases for each type of variables. Let's begin with the pointer. If our variable is a pointer, then the naming convention should have a prefix, and that's the letter P. So for instance, if I define a character pointer, and this is going to be for farm name, then I should start with the letter P as a prefix. And this is going to be farm name as an example, and maybe this is El Khadim. This is a farm nearby in our village. So the point is, if if you're naming a pointer variable, you should use a prefix, and that's the letter P. And that's very simple. And now in the case of a double pointer, you should use double P's. So for instance, if I have a function that takes on a pointer of character double pointer and changes its value, this is a very common use for double pointers in C applications, then I should put double P's as a prefix. Let's have a look at this example. So if I have a function, and this function is called select strongest Wi-Fi, that's probably a real case scenario, and you want to pass the character pointer array that holds the strongest Wi-Fi name. If we want to change it inside this function, we have to pass it as a if we want to change the pointer to points to another Wi-Fi name, we need to pass it as a double pointer, but that's another topic. But the whole point here is how to name a double pointer variable, and that's going to have two P's as a prefix, and then I can just say Wi-Fi name as the name of the variable. I hope that's clear. So for single pointer, we just add the letter P as a prefix. For a double pointer variable, we use double P as the prefix and then followed by whatever variable name we'd like to choose. Now let's look at Boolean. For Boolean variables, I use the prefix the letter B. So for instance, let's define a Boolean variable. I'm going to call it isLightOn. It needs to take a prefix, the letter B, and then I can name my variable isLightOn. And my light is on. And also, in order to use Boolean variables, we need to include the standard Boolean library to our main file. So that will be std_bool.h. Otherwise, the compiler might throw an error, although some compilers already define this library at the background by default. So this is how to name a Boolean variable. We add the letter B as a prefix. Now let's take a look at a more advanced case of variable. Let's look at handles. So if I have a handle here, and it's normally it's a type diff of a structure that holds multiple variables in a structure form, and it's a handle for a device, bus, or some physical device. This is normally called handle in embedded system. So let me give you this very quick example. Let's say that I've got a structure that holds my R2C bus handle parameters. So this is a type diff struct, and if you don't know how to use type diff, I would advise you to just look back at the basic C programming tutorials from any source to learn about them, but we're going to focus on the naming convention in our case. We're not going to get into the details of the types of variables. So for handles, let's say this one is an I2C handle, and it takes the suffix t for a type diff. We're going to learn more about those in a later video, but the point is, let's say that this one holds multiple variables, the slave address, and remember the rule, you should align the names. So we should always follow this rule. So Boolean is active, so if the I2C active, and then probably the last variable could be a timeout for our I2C bus. So this is a millisecond timeout, and we should follow the camel case convention, and let's not forget to align all the variable names, because they're defined in a sequence, one after the other, just like these variables we had in the main. Okay, now for handles, if I want to define this handle into my main, then the naming convention for this one shall have the letter H as a prefix. So it's going to be an H, and then let's say this I2C handle belongs to my temperature sensor. So I'm just going to say temp sensor. Okay, and now that's because it has the letter H as a prefix, we know this is a handle variable. and then we will deal with it this way. If it's a handle, then we expect that it has parameters like a structure, is active, and so on, and now we can assign those variables if we like. Okay. And same thing, the bonus rule 3 is to align the variable assignments too. And let's say the address is 12 in hex. Okay, so that's how to name a handle variable. Now let's look at global variables. For global variables, we also have a specific rule. So if I have a variable, let's say my total green apples, I want to make it a global variable. So instead of defining it locally in a scope of a particular function, I want to define it global into my full source file. Then I need to take it out from here and put it outside here fully on my main file, on my main source file directly. Okay. Now I just remember one thing on the fly. I started using these unsigned integer variables, and I haven't included the required library for them, which will be a standard integer library. So now if I try just to build it, I don't expect that to build. It should throw an error. Exactly, so it's not recognizing these variable types. So therefore, it just came on top of my head right now. Let's do it before we continue. So that's going to be standard integer.h, and this one should get rid of those errors. Okay, excellent. We haven't got any errors. We've got just a few warnings, and they generally say you have defined a variable but you haven't used it. That's not a big issue here. Okay, now back to our global variable. Now, if I define my total green apples as a global variable, which means it has the full scope of the source file, I need to use a prefix, which is the letter G for global. So this one is going to have G, and then the total word will start with an uppercase because of the camel case convention. Since G has already started with a lowercase, then every following word has to start with an uppercase. And that's how to follow the naming convention for a global variable. And additionally, if we have a global variable and we don't like any other C files to have access to this variable, and we want it only for the main.c, we should use the word static to limit the scope of this variable to this C file only. Okay, now let's discuss something further for variable naming conventions. What if a variable has multiple types? It's a handle and also a pointer. Which one shall you follow? Shall you combine the two? So if this one is a pointer, what shall you do? So the naming convention rule states that you should follow the priority rule. So priority for naming prefix if we have multiple types. Okay, so if a variable, so if our handle is a pointer, then the rule says we should follow the pointer only, so it should only be a p. Let me explain. So the priority rule says that the strongest naming prefix is global, because if a variable is global, you should always put the global prefix. So the strongest one is global. If a variable is both a global and a Boolean, for instance, it should take the form G, just like this one. Okay, I'm going to give you examples in each cases, so just bear with me a minute. So global is the strongest. Which uses the prefix G. And then pointer is the next one, and that uses the prefix P. Pointer or double pointer is the same. And then finally, the weakest one is the normal type. So it's like if it's just a variable, like the total green apple, or a Boolean variable, or a handle. Those are the normal types. Those are the weakest one of them all. So if we decided to make this Boolean variable a global one, then global is the strongest. So if this one is global and Boolean, we shouldn't put the B, we should rather put the G prefix. So if I want to move this out of the main function and define it globally like this, then I should change the prefix from B to G, because global is the strongest prefix of them all. Now similarly, if my handle is, if I want to define my handle as a pointer, then pointer is stronger than handle. So if it's a pointer, I cannot just say a pointer handle, it just has to be a P. Okay, these are the naming convention rules if we have multiple types at the same time. Now, also, if this handle pointer became global, global is the strongest, so we should change the prefix to G, and so on. So I hope you get the idea by now. These are the priority for naming prefix naming convention if we have multiple types. Okay, now and finally, let's look at variable keywords. So variable keywords, it's a very important subject that you need to be quite aware of the rules associated with it. So keywords are constant, static, and volatile. These are keywords that belong to variables. So let's begin with the constant keyword. The constant keyword is a very simple one. The constant states that if a variable doesn't change in runtime or doesn't change as a parameter to a function, we should define it as constant. So for instance, my farm name, this is a constant. So if this one is my farm name, like the farm name, this one, so this one needs to be a constant because I don't intend to change it. Similarly, if I have a floating point that maybe belongs to the math pi constant, then which is 3.14 something, this one is a constant. We don't change this math constant in runtime, so we should always define it as constant. So that's the constant keyword. Another very common use for the word constant is when you're trying to pass a variable to a function. You should also use the word constant if you don't intend to change that variable inside the function. Let's take a quick example. If I have a function that prints out the speed, then this function has the following name, print speed, and it takes a integer parameter called vertical speed, and it's simply just do a printf for this vertical speed variable, and it says vertical speed is equal to the whatever parameter you pass into this function. And because this variable is only going to be printed as part of the function and we don't allow anything to modify it, we shall always, it's a good practice to define the function parameter as constant. Although when you call it in the main, your vertical speed parameter might actually be normal, not constant. So this could actually be integer my vertical speed, and that's equal to 12, let's say. This is not a constant variable, but because I'm passing it to a function and I don't want the function to modify this variable, then I should declare the function prototype and the function parameter as a constant variable. So when I call it into the function, it's not going to allow it to be modified as part of the function. Now, in fact, let me try to run this code and see what do I get as a result. Okay, we've got an error. That's because we changed this handle. So I'm going to get rid of this line of code. So now it is successful. Let's head to our project location, the debug folder. We should see an executable file there. So let's run the executable, and here we go. We see vertical speed equal to 12, and because we didn't put a new line, it printed hello world 2 at the same line. So I can just simply add a new line there with the line feed character, and now I should be able to see that printed in new line. Here we go. So vertical speed equal to 12, it ran without any issue. However, if someone came and tried to modify my code later and decided that, hey, I'm going to add 1 to this variable, I'm just going to say vertical speed equal to plus equal 5 and just want to add 5 to the vertical speed variable. The compiler won't allow it to modify the variable because it's passed as constant. So let's try to build it. Exactly, we've got an error, and that's the type of error that we like, because we can detect programming issues in runtime when we in compile time, because we don't expect this variable to be changed, especially if this was passed as a pointer where you have the ability to change it. Then should always put the constant keyword to prevent anyone modifying this variable from inside the function scope. Although in the generic scope, or in the main scope, this one is not a constant variable. So that's the second use for the word constant, and it's a very useful one, and it's used quite a lot. It's always a very good practice to stick with this particular use. All right, so that's for the word constant. Now let's go and talk about the word static. Now the word static is very simple. It has got two main uses in embedded C programming, and generally C programming. The first use is to limit the scope of a variable to this particular C file, like what we have with the green apples. If we try to call the total green apples from another source file, so if we have another source file other than main.c, we won't be able to access this variable because it's defined as a static inside the source file. And the second use for the word static is to define a variable only once, to initialize a variable only once inside a function. So let me give you a quick example. So if I have a function that increments a variable, so let's say that the function is an integer, returns an integer, and it's called increment counter, and it takes no parameter, and it has its own internal counter that when we call it increments and returns that back to us, or returns that back in that increment. So in this case, we can initialize a variable, let's say integer counter equal to 0, and then we want to increment the counter and then return the incremented value. Okay, so at this case, if I just initialize a variable like this without the static keyword, each time I call this function, this variable is going to be initialized. So let's do a quick experiment. Well, in fact, let's do it the other way. So if I put the word static, then this variable is only going to be initialized once at the lifetime of the software. So if I call it for the first time, it's going to initialize the variable counter to 0, and it's never going to initialize it again. So if you call this function again, this line is going to be skipped, and the variable will be retained in memory with its previous value. So if the previous value was 1, then it's going to be 2, 3, 4, and so on. So if I run this code in my main, so if I do print counter equal to and it's an integer, and if I try to call this function here in my main, and let's say I want to call it multiple times, like maybe 4 times, let's see what we get at the output. Running our executable, and you can find that in your project location and into debug folder. So I just want to modify this. I like to always use a new line to make it more readable. Okay, let's have a look again at the executable file. So here we go. So now the counter is 1, 2, 3, and 4 because we use the word static. And this is going to initialize this variable only once, and then any consecutive call to this function will only implement the rest of the lines and is going to skip the static. Now, if I remove the word static, then this is going to be a normal initialization that whenever we call this function, it is going to initialize this variable and then it's going to return it. So if we call it 4 times, we should only expect to get 1 all the times because 0 plus plus is always 1. So let's try that. I'm sorry, terminal was open. And now let's run the executable. Here we go. Exactly, so the counter always 1, and that is the second use for the word static, although this use for the word static is generally not recommended, especially if you have multiple threads application. This can cause problem if this function is called from multiple locations, so generally you are not advised to make use of this static keyword in this form, unless you really know what you're doing. Okay, and now finally, let's have a look at the keyword volatile, and it's a very interesting one, and it's very important to know how it works. So the keyword volatile prevent the compiler in making any assumptions about the variable, especially if this variable is modified from a main routine, like inside a main function, and from an interrupt routine. An embedded C interrupt routine is very common, and that's if the microcontroller has got some hardware interrupts, like a timer interrupt thing. This is called an interrupt routine, not the main routine. It's going to stop the main routine for a little bit of time, and then going to come back. So let's take an example for the use of the word volatile and why it's very important to always include it when necessary. So let's say that I have a global counter tick for my delay, and this counter tick gets incremented in an interrupt routine, and an interrupt scope. So let's say that my variable is an unsigned 32. It's a global one, so I'm going to put the prefix G, and it's a let's say counter ticks, and it's initialized to 0. And I want this variable to be only accessed at this source file, so I'm going to use the word static, and that's a good practice as well. And let's say that this variable gets incremented from an ISR routine, so maybe systic ISR, in case of an STM32. And on the interrupt routine, this variable will get incremented at a rate of 1 milliseconds, or basically 1 kilohertz. So this one is going to get incremented inside the interrupt routine. And let's say I'm trying to add a delay inside my main. So I'm going to take the initial ticks. That's how it's done. So start tick is equal to the global counter tick at this particular time. And then I'm going to wait on a while loop for until the difference between the current counter and the start counter or start tick is so while this one is less than 1,000 milliseconds, which is a 1 second delay, is going to stay on this while loop until the counter gets equal or bigger than 1,000, then it's going to move into the next one, and this effectively will create a 1 second delay, assuming the counter gets incremented at an interval of 1 millisecond. Okay, now if we've done it this way without the keyword volatile, then what the compiler is going to do when it comes to this line most probably is that it's going to make an optimization. It will recognize that this variable is being used here, and then we do a comparison with this variable, but we don't see any increment for this variable inside the while loop. So it's going to assume this variable never changes. So if its initial value was, let's say, 1, 2, 3, 4, for example, because we haven't got any code in between to increment or modify this variable, it will always keep it 1, 2, 3, 4. And 1, 2, 3, 4 minus the initial value, which is also 1, 2, 3, 4. This one will always be 0 and will always be less than 1,000. So therefore, it's going to get stuck at this while loop forever. And that's not the behavior we want. So because of the fact that this variable is being modified from the interrupt routine and the compiler doesn't recognize that, so we need to use the word volatile for this variable. So we need to add the keyword volatile for this variable in order for the compiler to never make an assumption about this variable. And you cannot use the word volatile for every single variable, where you're going to get some undesired behavior or undesired results. So you should only use the keyword volatile when it is required, like in this case, a variable being modified from an ISR routine. Okay, and this sums up all the rules that I have for variables. And this brings me to the end of this video. Thank you for watching.